Hello everyone, welcome to this session number 12 on land use land cover mapping using QGIS as part of the online training program on Introduction to Remote Sensing and GIS using QGIS. In this session, we will be preparing a LULC map for Pune region using a plugin known as Semi-Automatic Classification Plugin or SCP plugin in QGIS. As you may be aware, LULC map is a very key input for hydrological modeling as it defines the translation of rainfall into runoff. Many of the times we don't get access to LULC map, representative LULC map for usage for conducting any hydrological analysis. With this semi-automatic classification plugin, it is possible to define your own LULC map with right kind of training inputs. You can generate a highly accurate LULC map. The semi-automatic classification plugin allows for supervised classification of remote sensing images, providing tools for download, pre-processing and post-processing of images. It was developed by Luca Congedo in the year 2012. The current stable version which is available for download from plugin repository is 8.2.2, updated in January 2024. However, this latest version is not comprehensive in the sense it doesn't have the capability to do the unsupervised classification. The options which were earlier available with earlier versions are not available with this latest version. So we will try to have a look at the older version for doing the unsupervised classification for if time permits. For more information about this SCP plugin, you can visit this website from gis to rs.blogspot.com. For installation of the semi-automatic classification, you can check its documentation. The semi-automatic classification plugin, as it says, it requires installation of additional dependencies, and you can install it using network installation in Windows 64-bit system. If you remember, when you at the very beginning we stated that QGIS can be installed on your system in two ways. One is by standalone installer that we had done, and another way which is meant for advanced users is this network installer OSGeo for W network installer, where you will have the flexibility to choose the packages which are required. Here also the semi-automatic classification plugin requires some packages which we can choose to install. So if you want to install this plugin, we have to first install all the required packages of remote year sensors, GDAL, NumPy, SkyPy, as well as scikit-learn and PyTorch. So for that, you can go to the main menu, go to the QGIS folder. You can launch this OSGeo for W setup. Click on S and go further with the same default options. Where it will come to a point of select packages. You can check for the various packages which are available here under libs. You can search for remote year census. It is already the version 0.2.1-1 is installed, whereas the requirement, if you see, if you check if there is any, I don't think there is any upgraded version, so you can keep it, and then you can look for scikit-learn, which is not yet installed, so you can install 0.23.2-2, select it, and then you can search for torch PyTorch, which is another Python library. The version which is available is 2.0.1-1. So after selecting the packages, you can check next. QGIS is already installed on your system, so it is not required to be selected. So you click on next, then it will install all the packages and their dependencies onto your system. You agree to the license terms whenever it asks for. So this is how we can make use of network installer for installing specified packages and their dependencies. Now let us run, once the next network installer has installed all the packages and the dependencies, you will get this installation complete message, and then you can click on finish to complete the installation. And now you can go open your QGIS from the start menu, go to plugins, manage and install plugins, and then under all plugins you can search for semi automatic classification plugin. So you can see the description of the semi-automatic classification plugin, what it does, the rating and number of downloads, tags, etc. The available version, latest version 8.2.2, and then you can click on install plugin while connected to the net to install the semi-automatic classification plugin. In this way, we have installed the dependencies of packages selectively using the network installer and then the semi-automatic classification plugin. Now once it is installed, you will find a new panel of HCP doc has been added here, and also a new menu item of SCP is added to your QGIS, from where you can access these functionalities for creating the training inputs and processing, pre-processing. The same options will also be available through SCP doc. Now let us move further. You have already seen the concept of spectral signature and basics of image classification in the earlier sessions. Just to recapitulate, image classification is a process wherein the pixels of the satellite imagery are grouped as per their spectral characteristics and assigned land cover classes. Each object or each feature on the Earth's surface has its own unique spectral signature, which is the plot of reflectance as a function of the wavelength across the electromagnetic spectrum. Each energy reflected by various features of the Earth's surface or a variety of the different wavelengths is used to build a spectral response of the feature, which is useful for its identification. Now, if you have a multispectral satellite imagery dataset available, and because you know each feature or each object on the Earth's surface as a unique spectral signature, you can use various band combination of these multispectral imagery and try to identify and assign each pixel to a land cover class or a land use class. Thereby you generate the land use land cover map. Now if you have some ground information, the actual ground information of the land cover classes, you can define the training input with the known information, and each pixel is compared to the training input, training classes, the training samples, and it is assigned to the land cover class depending upon the spectral similarity. This is what happens in supervised classification. Which will you can have an accurate the accuracy of the land use land cover map generated will be better if you have better training samples. There are set of guidelines which may be followed for generation of the better land use land cover map. Like your training samples should be distributed over the entire image. They should not be of they should capture enough spectral variability of that particular class, and they should be larger in number, at least 5 to 10 per class, etc. There are some, if you follow this procedure, if you define more multiple training samples or a region of interest, and then you classify, you will have better accurate land use land cover map. In unsupervised classification, the user only specifies the number of the classes, and the clustering of pixels based on their spectral again based upon their spectral similarity with defined spectral threshold. The clustering takes place, and the user has to define or assign those cluster of pixels to a user land cover class later. So, but how often what happens is generally the because of the presence of shadows or because of the presence of clouds, and because the training sites in case of supervised classification are not delineated properly or without capturing enough variability, there will be misclassification of various pixels as other classes, and in some cases generally the misclassification, the land cover the some land use land cover classes are spectrally similar, therefore the misclassification happens. For example, the land use class of crops is often mixed up with the forest land cover class, and the built up land use class is often with mixed up with the bare soil land cover class. And even it also depends upon the spatial resolution of the imagery. Unless you have very fine spatial imagery, now we have access to Sentinel-2 multispectral satellite imagery with 10-meter resolution. And Landsat is earlier it was used, and the resolution is 30 meters. Now, if in a 30-meter resolution, for example, in an urban area, uh, even though when you define a training input in a better way, because in a 30 by 30 meter resolution in the urban area, it may be containing not just buildings, it may be having even vegetation, bare soil, and a lot of land cover classes. So there will be a homogeneity there will be a variability of a lot of variability in case of urban built up spectral signatures, and they will be spread over across the spectrum. So they are often confused with many other land cover classes. So that cannot be avoided unless you have very fine resolution of multispectral satellite imagery. So we will see these aspects, various aspects, when we do the hands-on. There are many satellites acquiring the multispectral imagery. During this training program, we will be looking at the optical or the visible range and infrared range of the electromagnetic spectrum. For land cover monitoring, the Landsat series and Sentinel-2 satellite acquired multispectral imagery are very useful. They are freely available for download. The Landsat series of the satellites were launched by NASA, and they are acquiring imagery since early 1970s. So we have a long time series of the imagery available, which is very useful for change detection analysis. They are available at a resolution of 30 meters. Currently, the Landsat 8 is operational, and Landsat 9 is the latest satellite, and its imagery have become available for download. Both Landsat 8 and 9 have operational land imager and thermal infrared sensors. They acquire data in 11 bands. For land cover classification of a particular interest are the band 2 uh,
corresponding to the blue band, band 3 green, band 4 red, band 5 near infrared, and band 6 and 7 shortwave infrared 1 and 2. In this training program, we will be using the Sentinel-2 multispectral imagery for generation of land use land cover maps. The Sentinel-2 satellites were launched by European Space Agency as part of the Copernicus Land Monitoring Service. They acquire the data in 13 bands. Depending upon the bands, they have a resolution of 10 meters, 20 meters, and 60 meters. For land cover classification, we will be using band number 2 that corresponds to the blue band, then band 3 uh, corresponding to green band, and band 4 corresponding to the red band, and then band 8 corresponding to the near infrared, then band 11 and 12 corresponding to the short wave infrared 1 and short wave infrared 2 bands. The thermal bands are generally avoided for land use land cover classification.
You can launch the semi-automatic classification plugin from the main menu. You will find all the options under SCP main menu, and also you will find the dock, SCP dock, which must have been added as a new panel after installation. And also after at the time of installation, a new toolbar, semi-automatic classification SCP plugin toolbar, working toolbar has been added as a new toolbar. You can launch the semi-automatic classification plugin by clicking this symbol. So then as a first step, we will first download the products. We will download the Sentinel-2 imagery level 2 products, that is surface reflectance products for Pune region. The most recent images we will try to download, and then we will try to do the land use land cover class supervised classification to generate a land use land cover map. Now this if you see this download products option, you can see that the current version, the latest version, it offers two sets of imagery which can be directly downloaded from the plugin. One is Copernicus data space ecosystem, for which we had introduced it in the session on open access dataset, and I had asked you to create login credentials for this Copernicus data space ecosystem, and then earth data .nasa.gov, which can be used for accessing the harmonized Landsat Sentinel-2. But we will not be doing this using this dataset. We will be only using the Sentinel-2 10-meter resolution dataset. So you can input both these logins. This is different from Earth Explorer, if you can remember. So let me add my password, login credentials here. Sorry. Yeah. And after adding login credentials, you can check this remember. If checked, the username and password locally in QGIS, the password is stored unencrypted. It is giving you a warning. You can remember. So the password is stored unencrypted. So again, you can go to SAP plugin, download products. You can also input your Earth data, NASA data login, but for the time being, I am not doing it because we will not be using that. So let us try to look for the data sets by clicking this on this search button after inputting your login data. Here you can give your search parameters. Before giving the search parameters, you can click on this add OpenStreetMap to the map and click here, and you can verify that OSM map has been added to the map canvas area of QGIS. Now I am closing this SCP doc. It will be not needed for the time being. So OSM street map has been added. You can zoom to your area of interest. I will zoom to Pune. The region covering Pune are the region for which I want to generate the land use land cover map. So yeah, so you can keep this extent, and then you can go to this download a products tab, search tab, and you can give the inputs of a bounding box, the upper left and lower right coordinates, latitude, longitude and latitude, or you can use this set area in the map option to take your mouse and use the left button to click the left side topmost uh, point of the bounding box, and then you use the right button of the mouse to click the rightmost bottom point of the bounding box. Then you see this area has been bounding box has been generated, and now and I will also see that these lat long of these bounding box has also been populated, and you can check the Sentinel-2 product, and you can search the data sets, say from 1st February 2024 to the current date 22nd February 2024, and you can set the maximum cloud cover that you can allow, because presence of clouds will create issues for signature. It will create an issue for accurate land use land cover classification. But however, because we are in the month of February, relatively there will be no cloud cover. Anyway, I will keep it as it is. I will not do anything, and then you can increase the number of results for these many days. Sentinel-2, which has a revisit time of 5 days, there will not be more images. You can keep the results to 20, and then you can click on this find button. Then what it will do is it will fetch the scenes of Sentinel-2 intersecting this bounding box, which is covering the Pune region for the date range, and given a cloud cover. But here we have cloud cover, we have allowed up to 100% cloud cover. We are not filtering the results on the basis of cloud cover. We are only filtering the Sentinel-2 imagery on the basis of date range and on the basis of our bounding box. You will find the list of products in this box once it fetches the data. As you can see, this is the progress It is searching. The search is in progress. The time elapsed is 53 seconds, and it will take 1 minute 19 seconds more for completing the search. So let us wait for 1 minute. Meanwhile, if you haven't yet created Copernicus or ecosystem, data space ecosystem login, you do that, because it will be needed for fetching the data and using for use of Sentinel-2 imagery, multispectral imagery for land use land cover classification. You can do it for the same Pune region, or you can do it for any other region. You follow the steps. So you have this list of products. Now let me maximize this window. So you have these 16 products. There are level 1 products which are starting with L1, and there are also level 2 products. Now we will be selecting the level 2 products which are surface reflectance products, which will be more suited, because surface reflectance products, the atmospheric disturbance correction, the atmospheric correction has already been applied to get an estimate of the surface reflectance. So you can check the level 2 products, and you can also see the cloud cover. As I said, the cloud cover, maximum cloud cover was 18 on 13th February. So you can see that the cloud cover has been very low. You can select the image with zero cloud cover. So such images are from 2nd 18th February and 3rd February, and again 18th and 3rd February. Maybe these are these may be the tiles, adjacent tiles. Let us check by clicking on the preview. Uh, Let me select this 18th February image. So you can see this is the image, and I know the locality, so I can see that it is covering my entire Pune city, as well as the surrounding areas of for reservoirs, hills, and downstream agricultural lands, command area of the Kadakwasla Dam, and other projects. Everything is being covered. So, and also the cloud cover is zero. So it is a very good imagery for doing the land use land cover classification. So I can select this. If you want to look at more images from the same day, yeah, from the 18th February, there is one more image. Let us check its preview. And most likely it is the tile next to the previous tile. So yeah, this is the tail end of the Ujjani reservoir. It is downstream of Pune, not actually Pune. So I will go with the image from 18th February, the latest imagery which is available here of Landsat level 2 product, Landsat 2 level 2 product from 18th February with the zero cloud cover covering the Pune region. And this is in my preview, and you can add it to display preview of highlighted this image, highlighted image. You can display it in your map. Now let me click this, then check your QGIS. Now this QGIS image is a temporary image, as you can see the preview image at a low resolution, and you can just check the area that is being covered by this imagery. The entire Pune metropolitan area and the Western Ghats and the downstream, some of the downstream regions are being covered. It is good enough. So you can go ahead, and for it is you can download the data set. So here, for downloading the data set, you can select bands. Now band 1 of Sentinel 2 is similar to blue band, which we can avoid working, but you can include it, there is no harm. Then band 2 is the blue band, green band, red band. Then band 5, uh, band 6, band 7. These are the bands of vegetation edge. Then band 8 is a near infrared, and then band 9 and band 10 are thermal infrared bands, which you can avoid including for your classification. And then you can include 11 and 12, which are sphere 1 and sphere 2 bands, and you can also include ancillary data which contains metadata. So you can select these bands. You can also uncheck band 1, so you can finalize band 2, 3, 4, 5, 6, 7, 8, 8A, 11, 12, and ancillary data. And you can check this box, that is, you want to download these bands only if image is previewed in your QGIS map canvas. Yes, it is in the preview of my QGIS map canvas. And then you can uncheck this pre-process images. We will do the pre-processing separately. You can check this load bands in QGIS so that the bands will be loaded in QGIS, or otherwise also it will be downloaded. So everything is set. You have finalized the image. Now you can click on this run and define a directory where you want to download your images. Now I can go to my day 4. Then I will create a new folder of exercise data session 12 and select this folder. Once you select the folder, the download will start. So the data is being fetched from the Copernicus data space ecosystem by through this plugin without going to the portal of Copernicus ecosystem plugin, data space ecosystem. Now this may take some time. Now you can wait for the download of your bands, and then you can check them by loading in QGIS. If you open your QGIS map canvas area, you will find the download progress, how much time has elapsed and how much time is remaining. So you can see how much the download progress you can see. There is one tip for increasing the speed of download. You can go to SCP menu and then go to settings. While this is happening, it will not improve the speed, but if you are yet to download, before downloading you can change this setting of going to go to settings. What you can do is you can increase the available under system settings, you can increase the available RAM to about 50 percentage of your system RAM. Suppose your system has 8 GB RAM, you can increase the available RAM for up to 4096. If you if your system is 4 GB, has 4 GB RAM, you can increase it to 2048. Because it is downloading, I am unable to open the settings. Otherwise my system will be it will be hanged otherwise, so I will not do anything. So you can yeah, you can go to settings and then select this processing setting, and then in under available RAM you can change. Now it is only 1961 in my case. Even though I have 8 GB RAM, I can increase this so as to fasten the process of download. Yeah, my download of data has been completed. Now I can go to SCP plugin and I will change that settings. And settings processing setting, you can increase the available RAM. Say in my case I will increase up to 4096, and you can also check this play sound when finished. When you check this, whenever your download is completed, the plugin will give you a sound which indicating that the process has been completed. So you can check this option. And now for the second step, before going to the second step of pre-processing the data, let me add my layers, downloaded layers to the QGIS panel and check. Now I will remove this temporary layer which was a preview layer. I will keep my open data, OpenStreetMap as it is, and to add my raster layers, that is the Sentinel-2 layers, you can go to you can browse to the um, location, that is day 4, exercise data, session 12. As you can see, a new folder has been created starting with L2A, Landsat 2A products, and then you will see the bands, how many bands have you selected and how many bands got downloaded. You can check that band 2, 3, 4, 5, 6, 7 are downloaded, but I see my bands 8, 8A, 11, 12, the download is not complete. As I can see, the download is not complete. Therefore what I can do is I can even if you are finding that you can check it by adding these layers to the QGIS map canvas area. And also you will find one file, mtd underscore msil2a xml file, which is a metadata file, which has to be in this folder, which will be useful for converting the digital numbers, the values contained in these layers, to reflectance values. Now let me add all these layers. 4 of my bands have not downloaded properly. I will add it, close. Now you can see only how many 2, 3, 4, 5, 6, 7 have been added. 8, 8A and 11, 12 are not added. Now let me I can do is I can run it again. Go to SCP, download products. Now I have increased my system RAM also, the available RAM also, and you can select the same imagery, and then you can display the preview of highlighted images in QGIS, and then you can see the bands that were selected. Now you can remove this band 2, 3, 4, 5, which have already been downloaded. 2, 3, 4, 5, 6, 7 have been downloaded. So I can deselect. My system has is running very slow. Yeah, 7. So I will only keep 8, 8A, 11, 12 bands, and then I will run it again. It will ask again for the folder. You can choose the folder. I think this external folder has to be chosen. So you can select this folder. Now the download will happen again. Now once all the bands have been downloaded, you can add them to the QGIS layer panel, and on the canvas area you can visualize them. You can check the each band's properties The CRS, it is the UTM zone 32643 43. This is a projected coordinate system, and then the pixel size is 10 meters resolution, the B2, the band 2. Maybe the other bands have maybe having a different resolution in Sentinel 2, and other image other the it is a .jp2 extension file. uh, then you can also check the values by using the identify features. Now these are not reflectance values, but some digital numbers which need to be converted to reflectance values. Now we will go to the next step of pre-processing the data. You can go to the SCP main menu and then go to pre-processing and then select the image conversion option. And now you can select the directory containing the bands. This is the directory containing the bands. I can select this folder. Now you will see all the bands have been added to the list. Now because these are level 2 products, the level 2 Sentinel images, they do not require this DOS, that is atmospheric correction, that is not required, dark object subtraction correction. Then you can uncheck this band set and use band set tools also, and you can create a new band set. And now you can run this pre-processing and save the converted bands in a new folder, converted. You can select this folder and run it. So it will again take some time for once the image conversion is completed, or pre-processing is completed. Now we will clip our data to set the area of interest to the local area, not for the entire scene of the Sentinel-2 tile. For that, you can first load your you can remove all these layers by right clicking. Let me see all my let me add my converted reflectance values, which will be in this folder of converted. So you select all the bands, add them. So you have the bands of B2. Somehow the band 8A is missing. There is some error and it is not getting processed. So we have band 2, 3, 4, 5, 6, 7, 8, 11, 12. 8A is not there. It has not been generated. Anyway, you can check the values by using the identify features. You will find now that the values are in decimals. These are the reflectance values. You can check the band 8, which is NIR band, where the reflectance will be high in the vegetated areas and low in the so this is band 8. Yeah, in water it is almost 0, and here sorry. Anyway, now these are the reflectance values. Then the next step is clipping the area, so that you do instead of Selecting the whole tile, you will do the land use land cover mapping for area of interest. So you can first create a band set. Going to the main menu of SCP, click on band set. Band sets are nothing but input images which will be considered for the analysis. These are the numbered sets of raster bands. Now we have to define a new band set. It has already been generated. What you can do is you can click on this button, add bands loaded in QGIS. Then you select all the bands and then add it here. Now you see the sequence. If it is from 2, 3, 4, 5, 6, 7, 8, 11, 12, fine. Now a new band set has been created. The band set this, this is the band set name. This will be the active band set which will be considered for further processing. You can delete any of the rows. You can move them. Now let us also look at the band quick band settings, where the wavelength you can select it as under Sentinel-2 imagery. Sentinel-2 bands, and the wavelength you can units micrometers, and the date of imagery, as you can see, it is from 18th February 2024. So select the year, month and date, and you can see the active band set has been defined. The date has been defined, and then the center wavelength has also come once you selected the Sentinel-2. Now once you set up these quick band settings, you can go for clipping. The option of clipping will be there under processing. You click this clip raster bands, and you can select your input band set. There is only one input band set that has been created just now. This is the input band set which will be used by clipping for clipping, and then you can for as you can see, all the individual converted images are prefixed with RT, which means reflectance. Now here you want to prefix clip one all the images. You can give it can be customized. So you let it be clip only. Then you can give the clip coordinates. You can select the area in the map by using this option. Go to the canvas area, hide all layers, only OpenStreetMap can be there. Now let's select our area for which you want to generate the land use land cover. So you can include these reservoirs, and then the main city, and then downstream area. So you click set the area by one left button, click on the left topmost point, and right button click in the right bottommost point in the downstream. So this is the area that you have set. Now all your bands, these bands 2 to 12, there are 8 bands, 9 bands in fact. All these 9 bands will be clipped. Make sure that your project coordinate is the UTM projection only, because all of your bands are in UTM. and the project coordinate is also in UTM because you are selecting the area on QGIS interface, so the project coordinate has to be changed, and then you can click on run. You can even use vector for clipping. You can upload a shapefile and use it for clipping the area of interest. If you have any shapefile, that can be used. Now you can create a new folder inside converted. You can name it as clipped, and you can select it, new folder, clipped, and you select the folder, and then it will run. It will clip all the 9 bands to the extent that you have selected. You can watch the progress in the main QGIS canvas. Once it is done, you will hear that sound. So all the clipping of layers has been done. You can see the change in the extent. The extent has been reduced. Now you can remove all the layers prefixed with RT. You no longer require them. Now you have 9 bands. Now the next we will try to define training input for training input file and generate training data sets, training input files for land use land cover classification. Now you have to again define the band set because you have clipped all the layers from the earlier band set. You go to SCP menu and click on band set. The old band set definition is here. What you can do is you can delete this band set, and then you add the bands which are loaded in the QGIS. Select all of them. Now a new band set has been created. You can check the band quick settings by selecting Sentinel-2 micrometers, and the date is from 18th February. Now this band set will become the input image for the SCP classification. Once the band set is defined, you can go to the SCP doc. If it is not visible, you can go to view panels and select SCP doc. Here you can define the training input file by selecting this option of training input tab. So you can click this button of create a new training input. So a temporary training layer vector will be added with .scp extension. You can give the name as training input, which will contain all the training data sets. Then save it. So as you can see, a temporary training input layer, vector layer, has been created. Now in the next step, we will try to create the ROIs, or region of interest, or the training sites, which will be used for supervised classification of your whole region. The better the training sites, are the better training input, covering all the spectral variability of all the classes, the better will be your final land use land cover map. So we will continue with the creation of training sites at the ROIs in the next second part of the hands-on session. And then once we create the training sites, we will try to generate the land use land cover map in the second session. Thank you very much.